49A asks which of the children are taller than the mean, and if they're taller, their z-score will be positive. So positive z-scores are Emily, Sarah, Carol, and that's it. For part B, which of these students are at the mean? The ones whose z-score is 0, right? If you have a z-score of 0, you're 0 away from the mean, so you are at the mean. So Jason and Juan are at the mean. And which of the children are shorter than the mean? Anyone with a negative z-score. So negative z-scores, Omar, Heather, and Kim. So we want to know what percentage of students have a score below 550, given that the mean is 500 and the standard deviation is 100. So I'm going to draw this out. If my mean is 500, when I draw my normal curve, I'm going to have a mean of 500, and I'm looking for students who have a score below 550. So if I put 550 here, I want to know how many students have a score below 550. And so these aren't z-scores. These are just regular old SAT scores that we need to convert to z-scores. So the 550, to get a z-score, you want to take the score you're looking at, so your score, figure out how far that is from the mean, so subtract the mean, and figure out how many standard deviations that is by dividing by the standard deviations. So our score is 550, so minus 50, 500, which is the mean. So we know that we're 50 away from the mean, and each standard deviation is 100 because they tell us. Standard deviation was 100. So if I'm 50 away from the mean, that is a half a standard deviation, 0.5. So my z-score is 0.5. I'm always going to round my z-score to 2 decimal places so I can read it easy off my table. So I'm going to do 0.50. So that's my z-score. The mean always has a z-score of 0. It doesn't really matter. You can put it in there if you want. And the z-score we're looking at is 0.5. So now we're back to doing what we were doing in the previous problems. We need the area less than a z-score of 0.5. So I'm going to look at my table. It's a positive z-score of 0.5, so I'll look at the positive side of my table, and I'll look for 0.50. So 0.50 gives me 0.6915. So from the table I get 0.6915, and because it's less than, because it's to the left of it, I'm done. That's my score. So we're following this idea again. If it's less than, I'm done. If I wanted greater than, I'd be 1 minus. If I had between certain scores, I will subtract them. So I was less than, so I'm done. 0.6915. So here they're telling us that the mean is 7.6, the standard deviation is 0.4, and they want to find the probability of being between 7.4 and 7.7. So I've drawn it here. You've got a mean of 7.6 in the middle, and you want to know the probability of getting between 7.4 and 7.7. So you need to find 2 z-scores, one for 7.4 and one for 7.7. I want to find the z-score for 7.7 first, and remember to do it, you're taking the score you're looking at minus the mean divided by the standard deviation. So the score we're looking at here is 7.7 minus the mean is 7.6 divided by the standard deviation is 0.4. Pop that in on a calculator. So this is 0.1 on the top, 0.4 on the bottom, and that's going to be 0.25. Remember, I want my z-score rounded to 2 decimal places so I can find it easy on my table, which is what I'm going to do next. So I'm going to take this to the table. It's positive, so I'm going to look at the positive z-score table, and it was 0.25. So 0.2, 0, 1, 2, 3, 4, 5, and it's 0.5987. So 0.5987. And remember, in this case, this is new, we're looking for stuff between these. So I'm going to find the score for my other, the probability for my other score, and in the end, I'm going to end up subtracting. Because if I'm looking for something between two scores, I'll subtract. So leave this guy be for a second and go find the other z-score, the one for 7.4. So z of 7.4, remember it's this your score minus the mean over the standard deviation. So our score is 7.4 minus the mean of 7.6 over the standard deviation of 0.4. And that's going to be 0.2 over 0.4. So 0.5. Remember, I'm going to round it to 2 decimals so I can find it easy off my table, which is what I'm going to do now. So if I've got a z-score of 0.5, it's positive. It shouldn't have been positive, it's negative, right? Because 7.4 minus 7.6 is negative 0.2. So that's negative 0.5. So I'll look at the negative z-scores, so negative 0.50. So 0.3085. So 0.3085. And then when it's between, I'm just going to take those numbers and subtract them. So I'm going to do 0.5987 minus 0.3085, and that's going to give me 0.2902. And that is my final answer. Now, if you had accidentally done this guy minus that guy, you would have gotten a negative 0.2902, but just disregard the negative. You're not going to have a negative probability, so don't worry about it. Just go, oops, I should have done it this way. Your probabilities, your areas will always be positive. So we're done. So here they're telling us that there's a mean of 62, a standard deviation of 5, and they want to know what percent are traveling slower than 56. So if I draw it, mean of 62, standard deviation of 5, and we want slower than 56. So I'm not going to even bother putting the mean on here anymore. I think you don't even really need it. You just want, throw 56 on there. You want slower than it, so less than 56. We need to convert this to a z-score. So remember, to take a z-score, it's your score minus the mean over the standard deviation. So our score here is 56 minus the mean is 62 over the standard deviation is 5. And that's going to give me 56 minus 62 is minus 6 divided by 5 is going to give me negative 1.2. Remember, I kind of want my z-scores rounded to 2 decimal places, so I'm going to throw a 0 on it to make it better for my table. So when I go to my table, it's a negative z-score, so negative 1.2, negative 1.20, so 0.1151. 0.1151 is what I'm getting from my table, and I just have to figure out if I'm done or not. So I want the area to the left, or less than that, and if it's less than, I'm done. So hooray, that's my probability. Here they tell us we have a mean of 6.7, a standard deviation of 0.81, and they guarantee that they'll lose at least 5 pounds. So if they don't lose at least 5 pounds, they'll get a refund. So the people who get to claim the refund are the people who lose less than 5 pounds. So we want to find how many people lose less than 5 pounds, and they're the ones who are going to get a refund. So we need to convert this score to a z-score. So remember, to find a z-score, we're taking the number we're looking at, the 5, minus the mean, 6.7, over the standard deviation, 0.81. So 5 minus 6.7 is negative 1.7, divided by 0.81 gives us negative 2.098, which we want to round to 2 decimals. So if I round that, it's negative 2.10. Now I'll take it to my table, looking at the negative z-scores. Negative 2.10 is 0.0179. So 0.0179 from my table, and because it's less than the value I'm looking at, this is the score I want. I am done. So this one says a vending machine that dispenses coffee does not appear to be working correctly. The machine rarely gives the proper amount of coffee. Sometimes it's underfilled, sometimes it overflows. Does this variation indicate that the mean number of ounces needs to be adjusted? No. Indicates that the standard deviation is too large. So, sometimes it's underfilling, sometimes it's overfilling, it's all over the place. The amount of coffee that it's dispensing isn't consistent. So it's deviating a bit. So the standard deviation is too large.